Hello, everyone. Today we're going to be talking about how to find the rate of change of a quadratic function. Now, just to quickly review, when we're thinking about a quadratic function, we're thinking about a function that's got that U shape. So before, when you talked about the rate of change, you probably looked at rate of change in a linear function. And that rate of change should have been constant. It would have changed by the same amount regardless of which interval you were talking about. So when we talk about a quadratic function, it's going to be quite different because the rate of change is going to be very different when we're talking about the rate of change, let's say from this section in pink versus this section in blue. So the rate of change can be very different based off of the interval of a quadratic function. And remember, the interval is the starting and stopping value that is being asked of you. So what we're going to do is we're actually going to look back over what rate of change is. So the rate of change is when we have the change in y in our numerator over the change in x. So what you're going to be doing is you're going to take your y values and subtract them. So y2 minus y1. And you're going to divide that by the subtraction of your x values, which is x2 minus x1. And just a reminder, that triangle symbol means change. So simply the change in y over the change in x. So if we're looking at finding the interval for the rate of change in this given table, it says find the rate of change between -1 and 2. So we're going to be looking at the x values between -1, so here's -1, and the x values of 2. Well, when I look at these two values, and I'm actually going to look and analyze the table a little bit, I can clearly see in this table that it is a quadratic function. And the reason I know it's a quadratic function just by looking at it is because as my y values are changing, I can see that this section right here is symmetrical. I have 2, 0, 0, 2, and then that's that vertex section that is changing direction. So I can see this is quadratic, but honestly, the fact that it's quadratic does not change the process of the rate of change. So we're going to set this up. So we're going to do the change in y divided by the change in x. So I'm going to start with my y2. So I have y2 and y1. So we have 12 minus 0 divided by x2 minus x1. So this is going to be 2 minus -1. All right, so when I simplify this, I have 12 over +3 because 2 minus a negative becomes positive. So this is going to wind up having a rate of change that is equal to 4. Now, if I were to have a different interval that I was asking to find the rate of change, that change could be different. So let's choose an interval, for example. So let's say we want to do the interval between -3 and 0. Okay, so I'm going to do -3 and 0 here. So I'm going to do the same thing. I'm going to do my change in y over my change in x. And my change in y is going to be 2 minus 2. And then my change in x is going to be 0 minus -3. So 2 minus 2 is 0, divided by +3 is 0. So this has a change of 0. So between -3 and 2, there's no change because of the fact that they both have a y value of 2. That's where if I'm thinking about my quadratic, if they're both at 2, that's that change between those two values is right there at that same y value. So let's look at a few more examples that are not necessarily in a table format. So it says find the rate of change of the given function between -1 and 0. So when I'm looking at this quadratic, the first thing that I want to do is I want to identify my points at -1 and at the x value of 0. So I'm going to go to my x coordinate, and at x -1, I have the point -1, 0. And at the x value of 0, I have the point 0, -1. So I'm going to be looking at these two values, and you can make your own table if you feel more comfortable looking at it in that format. But I have -1, 0, and 0, -1. And they want to know the rate of change for that. So in order to do that, again, we're going to do the change in y over the change in x. So we're going to do y2 minus y1. So I'm going to do -1 minus 0 divided by x2 minus x1, which is going to be 0 minus -1. So we have -1 divided by +1, so my rate of change is -1. And again, if I were to choose any other interval, that rate of change may not be the same because it is a quadratic function. All right, looking at the last example here, we have find the rate of change of the given function between 0 and 3. So I'm looking between 0 and 3 for my x values here. So again, I'm going to go to my quadratic. I'm going to find the x value of 0, and I see that I have the point 0, 7. And I'm going to go find the x value of 3, and that point is 3, 1. I'm going to make a table just to organize it. And I'm going to do my rate of change. So the change in y over the change in x is going to give me 1 minus 7 divided by 3 minus 0. So that's going to be 1 minus 7 is -6. 3 minus 0 is 3. So my rate of change for this particular interval is -2. And now let's just kind of go back and look at what the rate of change is actually indicating for us. So when we're talking about this rate of change, we're talking about the change that happens between these 2 points right here, okay? So if I'm talking about the rate of change and I look at that -2, that's technically -2 over 1. So that means I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. Okay, and it lands at my other end value of that interval. Same situation happens with the other one. So if I'm looking at my rate of change and I'm looking between those 2 points, it's -1. So the same concept here, -1 over 1 means I'm going down 1, right 1, down 1, right 1. Okay, so the process is still the same, whether it's a quadratic, whether it's linear, whether it's exponential, it could be any function. You're still going to do your change in y or your change in x. The key is to identify what interval they're asking you to use.